Assalamualaikum and hi to all students watching this video. This video is for Program Kecemerlangan, Akademik KMNS, Score Program, Semester 2, Session 2021-2022. In this video, I will be showing you how to solve questions from PSPM 2019-2020, Chemistry 2 SK025, question number 1. Question number 1. The data for the reaction between methyl ethanoate with hydroxide ion at a certain temperature is shown in Table 1. Determine the order of reaction with respect to each reactant. To solve this question, students need to use the initial rate method. First, write the general rate law. Rate equals to K, concentration of methyl ethanoate to the power of X, concentration of hydroxide ion to the power of Y. Choose two different experiments for the reaction. For example, here I'm comparing experiment 3 to experiment 2. Substitute the values from each of the experiment using the general rate law. Solve these values and you will get 1.67 equals to 1.68 to the power of X. Therefore, X is approximately 1. Students may also write the order of the reaction with respect to methyl ethanoate is first. Do the same method to find the order of reaction for hydroxide ion. In this case, I'm comparing experiment 2 to experiment 1. Substitute the values for this experiment into the general rate law. Solve this equation and you will get 1.28 equals to 1.28 to the power of Y. Therefore, Y is equals to 1. Students may also write the order of reaction with respect to the hydroxide ion is first. These are the marks for this question 1A1. Next, question A2. Write the rate law for the reaction. Because we have found what is the order of reaction with respect to methyl ethanoate and hydroxide ion, we can substitute the values into the general rate law. So rate law is now rate equals to K, concentration of methyl ethanoate to the power of 1, and concentration of OH minus to the power of 1. And this is the mark for this question 1A2. Moving on to question A3, calculate the rate constant. You are given various experiment value for this reaction. You can use any of the experiment. For example, here I'm using experiment 1. By substituting the data from experiment 1 into my rate law, at 1.58 times 10 to the negative 3 equals to K, 0.05 to the power of 1, 0.12 to the power of 1. I can calculate my rate constant K to become 0.63 times 10 to the power negative 3. The unit of the rate constant can be derived by solving the unit for initial rate, molarity second minus 1, divided by molarity and molarity. Therefore, the unit of K for this reaction is molarity minus 1, second minus 1. Next, this is the mark for this question. Question number 1A4. How many times will the rate increase if the concentrations for both methyl ethanoate and hydroxide ions are doubled? In this case, you need to assume that both the initial concentration of methyl ethanoate and hydroxide ion to become 1 molar. So when the concentrations are doubled, at the new experiment, both concentrations will become 2 molar and 2 molar. So comparing the rate for the new reaction to the rate of the initial reaction, we will get the value of 4. So this means that when the concentrations of both methyl ethanoate and hydroxide ions are doubled, the reactions are 4 times faster or fourfolds, or quadrupled? This is the mark for this question. Moving on to question number 1b, the decomposition of ammonia to nitrogen and hydrogen at 450 degrees Celsius was studied on the surfaces of tungsten and osmium catalysts. The profile diagram for the reaction using each catalyst is given in figure 1. Question B1. Which catalyst is better for this reaction? Explain. Going back to the profile diagram, we can see here that when the reaction is using osmium as the catalyst, the EA or the activation energy is at the higher level on the energy axis. While if we are using tungsten as the catalyst, the EA or the activation energy is on the lower level for the energy axis. Therefore, the lower the activation energy, the better the catalyst for the reaction. So the answer is tungsten is the better catalyst. Reason why? Because it provides the alternative pathway that has lower activation energy compared to osmium. So these are the marks for this question. Question B2. The activation energy for the above reaction using tungsten catalyst is 163 kJ per mole. How many times faster is the reaction if the temperature is increased to 550 degrees Celsius? In order to solve this question, students need to use the derivation of Arrhenius equation, which is ln K2 over K1 equals to EA over R 1 over T1 minus 1 over T2. By substituting the value given by the question, which is the value of EA, R is the gas constant, and the value of the two different temperatures, we can find the ratio of K2 over K1. Substituting EA as 163,000 joule per mole, gas constant R 8.314, temperature have to be in the unit of Kelvin. Therefore, T1 is 723 Kelvin, which was from 450 degrees Celsius, while T2 is 823 Kelvin, which was from 550 degrees Celsius. Solving this equation, we get the ratio of K2 over K1 to be 26.97 or 27, which means it is 27 times faster when the temperature of the reaction is increased from 450 to 550 degrees Celsius. And these are the marks for this question.